A DC power supply consists of 4 major blocks. In this video, we'll be studying about each of them in detail. The first block of a power supply is the transformer. Transformer consists of 3 main parts: a core, which is typically made of iron, and 2 individual sets of wire coils. These coils are referred to as the primary coil and the secondary coil. When we apply AC current to the primary winding of the transformer, the coil creates a pulsing magnetic field. The core of the transformer works to direct the path of the magnetic field between the primary and the secondary coil and prevents wastage of energy. Once the magnetic field reaches the secondary coil, it forces the electrons within it to move, creating an electric current via electromotive force (EMF). A transformer's main function is to step up or step down the voltage from the primary to the secondary winding. This is done by simply adjusting the ratio of coils on one side to the other. If a transformer has 10 turns on the primary and 20 on the secondary, it will be a 1:2 step-up transformer, meaning the voltage doubles from the primary to the secondary. Now, if it has 20 turns on primary and 10 on the secondary, it would be a 2:1 step-down transformer. The second block of a power supply is the bridge rectifier. First, let us know what is rectification. Rectification is a process of converting alternating current into direct current. The component used as a rectifier is known as the diode. Bridge rectifier is more widely used type of full wave rectifier. It requires 4 diodes. In the following diagram, D1, D2, D3 and D4 are the 4 diodes. This is the positive terminal and this is the negative terminal of the diode. During the positive half cycle of the secondary voltage, diodes D2 and D4 conduct and diodes D1 and D3 do not conduct. The current flows through the secondary winding D2, RL and D4. During the negative half cycle of the secondary voltage, diodes D1 and D3 conduct and D2 and D4 do not conduct. The current flows through the secondary winding D1, RL and D3. In both half cycles, the current passes through the load resistor in the same direction. Therefore, a fluctuating unidirectional voltage is produced across the load. The third block of a power supply is the filter. Ideally, direct current is unidirectional and steady, but the output of a rectifier is not steady. It keeps fluctuating greatly with time. Such a waveform may be considered as consisting of a number of components. It has an average or DC value over which a number of AC components of different frequencies are superimposed. These undesired AC components are called as ripples. The AC components in the output of a rectifier produce variations in the unidirectional output voltage. The circuit used to remove the AC components from the output voltage so that a steady DC output voltage is obtained is called as the filter circuit. A smoothing filter is connected between the rectifier and the load. There are various types of filters such as the capacitive filter, inductive filter, LC filter, which is a combination of inductors and capacitors, and RC filter, which is a combination of resistors and capacitors. The capacitor input filter is an inexpensive filter used for light loads. It is directly connected across the load. Capacitive reactance is given by Xc, which is equal to 1 upon 2 pi Fc. Capacitor C acts as an open circuit for DC, that is, it does not allow DC and provides low reactance path for the AC components of the current. Now, the AC gets bypassed to the ground through C. The DC passes only through the load and produces DC output voltage. The capacitor charges up to the peak value of the input voltage and discharges through RL when the input voltage decreases below peak value until the input voltage increases to a value greater than the capacitor voltage. Then the capacitor recharges. The ripple can be decreased by increasing the value of the capacitor or the load resistor RL or both. The fourth block of a power supply is the voltage regulator. The battery in your car that gets charged from the alternator, the outlet in your home that provides all the electricity you desire, the cell phone you likely keep on hand every minute of the day, they all require a specific voltage in order to function. Fluctuating outputs that jump from plus minus 2 volts can cause inefficient operation and possibly damage your charging devices. There are a lot of reasons why a voltage fluctuation may occur. Example, condition of the power grid, other appliances turning off and on, time of the day, environmental factors, etc. The DC output voltage changes with the change in the AC input voltage. Therefore, to maintain a constant voltage across the load, even when there are variations in either AC supply voltage or the load current, voltage regulation is necessary. A linear voltage regulator works by automatically adjusting the resistance via a feedback loop, accounting for changes in both load and input, all while keeping the output voltage constant. There are various types of regulators such as the Zener diode, transistorized regulators, and the 3-terminal IC regulators. 3-terminal IC regulators require only a couple of bypass capacitors. They can supply large load current from 100 mA to more than 3 amperes. They are available in metal or plastic packages and they are inexpensive and easy to use. Because of so many advantages, 3-terminal IC regulators are widely used. There are two types of IC voltage regulators. First, fixed voltage IC regulators, and second, variable or adjustable voltage IC regulators. LM340 series is used as 3-terminal voltage regulators. It gives output voltage of 5 volts and maximum load current of 1.5 amperes. For adjustable regulators, IC LM317, LM338 or LM350 can be used. LM317 is a 3-terminal positive voltage regulator that can supply 1.5 ampere of load current over an adjustable output range of 1.25 to 37 volts. Sufficient heat sinking is necessary. This IC chip includes a series pass transistor that can handle more than 1.5 ampere of load current. The chip will automatically turn itself off if the internal temperature becomes dangerously high around 175 degrees Celsius. This is called as the thermal shutdown. Hence, when these 4 blocks, that is the transformer, bridge rectifier, filter and regulator, are connected in a proper order with correct values, they form a linear DC power supply, which gives you a constant DC voltage. Now I will show you a constructed DC power supply which uses IC7805 as a regulator IC and provides voltages from 5 to 20 volts.